This short reel documents a demo conducted in Italy in the fall of 2014 for a number of network architects and RF engineers from a Tier 1 multinational mobile operator and one of our global systems integration partners. We want to warn you before we proceed. Our customers report that what you're about to watch is unlike anything you've ever seen in wireless before, really, and it will change your assumptions about what's possible with NLOS wireless. First, a few words on the setup for context. We start with a relatively straightforward point-to-point link with a linear distance of 190 meters between the base location, what we call the concentrator node, or CN, and the remote location, i.e. the end node, or EN. Line of sight is completely blocked by 3 buildings between the EN and CN. In the baseline configuration, the nodes are aligned to take best advantage of reflections off of an apartment building on the right and diffraction over the rooftops of the buildings in the line of sight path. Looking at the setup from the CN end, you can see the CN on its pole to the left, the blockage of line of sight to the EN, which is positioned beneath the eave level on the far side of the 3rd building off in the distance, and the apartment building on the right. Throughout the demo, we use our mobile installation app connected to either the CN or the EN via Bluetooth to give us a continuous readout of link quality as we experiment with different configurations. The most important metric to watch in the evaluation of an NLOS system is how close it comes to maintaining its performance in an ideal line-of-sight link as conditions get more complicated. For Tirana's absolute air solution, that translates into maintaining enough clean signal-to-interference and noise ratio to achieve stable 256 QAM modulation, what we define as a full-rate link. Conversion from this to data rate depends on how much spectrum you're using, of course. Given our system's 10 bits per second per hertz of spectral efficiency for a single link, and a 40 megahertz channel, for example, this can mean a full-rate link of a healthy 400 megabits per second. The demo you're about to see involves taking a series of increasingly sort of crazy steps to try to break the baseline link by manipulating one end or the other of the link. As you'll see, nothing we tried broke the connection. We start with validation that the baseline link is achieving full rate using our smartphone app to report that link quality is in fact a 100% full rate. Next, we take the CN off its pole and point it directly at the first building to the northwest. Note that the node directions are highlighted on the map to the left of your screen for those of you trying to follow this at home. Raising the bar a little further, we point the CN straight east with the same full rate result. After pointing the CN to the southeast in the opposite direction of the EN, note, the system also maintains a full rate link. Since none of that was challenging at all, we go next to some of the slightly crazy variations in the demo. First, we place the CN face down on the roof, which in the end, that's a little harder, so that does limit us to a 79% of full rate connection. That didn't break the link though, so we tried putting it next in the metal hut on the roof that's next to that and closing the door with just enough of a crack to keep the Bluetooth connection working, if you're curious how we kept that going. Here the system was able to maintain enough of a connection through the RF leaks in the hut to achieve a 51% full rate. Still didn't break the link. From the hut, we move to the roof edge where we point the CN at the ground on the far side of the building from the EN, which is off to your right 3 buildings away in this view of the scene. This got us 74% of full rate. At the last test on the CN side, we pointed it at the sky, maintaining a connection off the sides of the antennas at 87% of full rate. On the EN side, where we go next, we were even more unsuccessful at degrading the link. First, pointing the EN to the northeast, essentially directly away from the CN, still gave us a full rate link. Pointing it northwest also yielded a full rate link. Taking advantage of an unused no parking sign that we happened to find leaning against the building foundation when we were gathering for this part of the test, we passed that up to see what would happen if we shielded the antennas with it, first from a short distance, as you can see, which had no effect on the rate. We then moved to the next part, which is putting the aluminum sign directly against the radome of the EN unit, also with no effect on the rate. In the final EN test, we point the EN directly at the side of the building, and once again we maintain a full rate link. While we're certainly proud of the unprecedented NLOS performance we've been able to achieve in the field, it's even more satisfying to see our customers and partners who've been frustrated by challenges with NLOS wireless get excited about the technology and express their confidence that it can help them address their network challenges.